All right, here's number 78, part 2 here, finishing off this review assignment. The graph of f is shown in the figure above. I think I thought 77 was connected to it, and that's what made myself confusing, and that's why it took longer than it should. This graph is here. And it says if you integrate from 1 to 3, the answer is 2.3. And the derivative of f at x is equal to f at x, then f at 3 subtract f at 0 would equal what? So from 1 to 3 is the area from 1 to 3. So this is that from 0 to 3. That's what it really means. So if they're equal to each other, instead of from 1 to 3, we're going from 0 to 3. So we know from 1 to 3 is 2.3. And then what part did we still need to calculate to add to that area is that rectangle, which is 1 times 2. That's 2. And then add it together and you get 4.3. And that's your answer. Let's see if I can do this one. I have a graph and the line x equals e, which is around 2.7. And the x-axis. So I'm going to find the volume. That's an integration question. Now, understand that ln 1 is equal to 0. So this is going to go from 1 to e. So if you looked at the graph, it would start at 1 going up. And it would look like that, which that line right there is e. Clear up. So we have to know where it intersects. Where does that intersect the x-axis, which is 0? So it's at when it's 1. So it goes from 1 to e, top subtract bottom, so that's the square root. So I'm going to write this as ln x to the 1/2 dx. Then it says that they're squares. So when I go top subtract bottom, the formula for a square is you square that base. So if I square it, they cross out and it's just ln x. So what's the integration of ln x? You'd have to use a calculator for this one. So I'm going to do it. Because we don't have a rule we have a rule to take the derivative of ln x. We just don't want to have to integrate it. So we're going to go menu, integrate, calculus integrate, from 0 to e. We can leave that empty, or we make it 1. E to the 1, e. And then it's just ln x dx. And you get negative 0.000. Oh, shoot. You know what I did? I didn't mean to do it from 0, right? We didn't do it from 0. We did it from 1 to e. My bad. And you get 1. There's your answer. Done. All that. Let f at x be the square root of x, and the rate of change of f at x equals c is twice the rate of change at x equals 1. Then what does c equal? So for 86, I'm going to take the derivative. That's what rate of change means. So this is really to the 1/2, right? So it's 1/2 x to the negative 1/2. That's the derivative of the square root. So the derivative at c is equal to 2 compared to the derivative at 1 that's twice as big. So whatever the derivative of c is, It's 2 times whatever the derivative at 1 is. So if I plug 1 into the derivative, 1 to anything is 1. That's just 1/2. So this is 2 times 1/2, and that answer is 1. Oh, sorry, 1 to the, yeah, so it's 1/2. So that answer is 1. You still got to solve this. So you're going to multiply by 2. This is complicated. C equals 1/4. Ugh. Move on. All right, 87. Looks like a calculator question. So you have an acceleration here, and at t equals 0, the velocity is -2. What values of t will the velocity of the particle be 0? When is it at rest? So let's integrate that. And we have a starting value of it. So we're going to integrate this. Let's do this on a separate piece of paper. So we have the acceleration. And so to find the velocity, we're going to integrate this. So I don't need, that's t squared over 2. That is negative cosine t plus c. Then it says, hey, plug in 0. And the answer should be -2. So wherever there's a t, plug in 0. That's 0. Cosine at 0 is 1, so that's -1. Solve for c, add 1. And now we have an equation. So there's my velocity equation. And I want to know when that's equal to 0. And you have to use a calculator. I got one of those. Again, I like graphing when doing this. So I'm going to graph it for trigonometry. Again, I'm going to go menu, actions, and delete all. I know there's a bit of a shine there. Okay, tab, and then type it in. I'm going to use x, right? X squared divided by 2. Subtract cosine x. Subtract 1. Oops, I didn't put that here. Tab. I do. X, move the cursor, subtract 1. Where does it cross over? So if you look at when it's greater than 1, you can see it's the line on the right. So menu, analyze the 0. That's 1. So we're going to press down and then highlight over it, and you get 1.478. .478. If you round it, the answer is B. All right, 2 more left. 88. Let the function f at x equal this, where h is the graph here. Which of the following could be the graph of f? So the graph of f is the integration, right, of this, the area. So from a to whatever it is to begin with. So the derivative is just what h is. So in other words, h is positive. So first it increases, and then it decreases, and then at b would be so it goes positive to negative. So I'm looking for a turning point at b. So these don't have turning points. This has a lower one. I need an upper turning point. No. Here, the derivative doesn't exist, but that's not true with this graph. The derivative exists there. So the only one that could match it in terms of increasing and decreasing is e. All right, number 89, or last one. A table of values of a continuous function is given above. If 4 equal subdivisions from 0 to 2 are used, which of the following is a trapezoid approximation of this? So trapezoid starts with 1/2. The equal width of each one is 0.5, also 1/2. And then what's the pattern? You start with the first height, and then you double the next height, and then you double the next height, and then you double the next height, and then it's just 13, and then we solve it. And if you solve that all the way through, 3 plus 6 plus 10 plus 16 and 13, and then divide it by 4, that is 48 there, and 48 divided by 4, the answer is 12. All right, Mr. G Math over and out. Great job doing the review assignment. Until next time.